What is parallel computing? Serial computing. Serial computing. Traditionally, software has been written for serial computation. A problem is broken into a discrete series of instructions. Instructions are executed sequentially, one after another, executed on a single processor. Only one instruction may execute at any moment in time. What is parallel computing? Parallel computing. In the simplest sense, parallel computing is the simultaneous use of multiple compute resources to solve a computational problem. A problem is broken into discrete parts that can be solved concurrently. Each part is further broken down to a series of instructions. Instructions from each part execute simultaneously on different processors. An overall control/coordination mechanism is employed. The computational problem should be able to be broken apart into discrete pieces of work that can be solved simultaneously, execute multiple program instructions at any moment in time, be solved in less time with multiple compute resources than with a single compute resource. The compute resources are typically a single computer with multiple processors/cores, an arbitrary number of such computers connected by a network. Parallel computers. Virtually all standalone computers today are parallel from a hardware perspective. Multiple functional units: L1 cache, L2 cache, branch, prefetch, decode, floating point, graphics processing input, integer, etc. Multiple execution units/cores, multiple hardware threads. Networks connect multiple standalone computers nodes to make larger parallel computer clusters. For example, the schematic below shows a typical LLNL parallel computer cluster. Each compute node is a multiprocessor parallel computer in itself. Multiple compute nodes are networked together with an InfiniBand network. Special purpose nodes, also multiprocessor, are used for other purposes. Why use parallel computing? The real world is massively parallel. In the natural world, many complex, interrelated events are happening at the same time, yet within a temporal sequence. Compared to serial computing, parallel computing is much better suited for modeling, simulating and understanding complex, real-world phenomena. For example, imagine modeling these serially. Why use parallel? Make better use of underlying parallel hardware. Modern computers, even laptops, are parallel in architecture with multiple processors/cores. Parallel software is specifically intended for parallel hardware with multiple cores, threads, etc. In most cases, serial programs run on modern computers waste potential computing power. Who is using parallel computing? Science and engineering. Historically, parallel computing has been considered to be the high end of computing, and has been used to model difficult problems in many areas of science and engineering: atmosphere, earth, environment, physics, applied, nuclear, particle, condensed matter, high pressure, fusion, photonics, bioscience, biotechnology, genetics, chemistry, molecular sciences, geology, seismology, mechanical engineering, from prosthetics to spacecraft, electrical engineering, circuit design, microelectronics, computer science, mathematics. defense, weapons. Concepts and terminology. Named after the Hungarian mathematician John von Neumann, who first offered the general requirements for an electronic computer in his 1945 papers. Also known as stored program computer, both program instructions and data are kept in electronic memory. Differs from earlier computers which were programmed through hard wiring. Since then, virtually all computers have followed this basic design, comprised of four main components: memory control unit, arithmetic logic unit, input-output, read/write. Random access memory is used to store both program instructions and data. Program instructions are coded data which tell the computer to do something. Data is simply information to be used by the program control unit. Fetches instructions/data from memory, decodes the instructions, and then sequentially coordinates operations to accomplish the programmed task. Arithmetic unit performs basic arithmetic operations. Input-output is the interface to the human operator. Flynn's classical taxonomy. There are different ways to classify parallel computers. Examples available here. One of the more widely used classifications, in use since 1966, is called Flynn's taxonomy. Flynn's taxonomy distinguishes multiprocessor computer architectures according to how they can be classified along the two independent dimensions of instruction stream and data stream. Each of these dimensions can have only one of two possible states, single or multiple. The matrix below defines the four possible classifications according to Flynn. 1. Single instruction stream, single data stream. 2. Single instruction stream, multiple data stream. 3. Multiple instruction stream, single data stream. 4. Multiple instruction stream, multiple data stream. Single instruction, single data system. Serial non-parallel computer. Single instruction, only one instruction stream is being acted on by the CPU during any one clock cycle. Single data, only one data stream is being used as input during any one clock cycle. Deterministic execution. This is the oldest type of computer. Examples: older generation mainframes, mini computers, workstations, and single processor/core PCs. Single instruction, multiple data sim. A type of parallel computer. Single instruction, all processing units execute the same instruction at any given clock cycle. Multiple data, each processing unit can operate on a different data element, best suited for specialized problems characterized by a high degree of regularity, such as graphics/image processing. Synchronous lockstep and deterministic execution. Two varieties: processor arrays and vector pipelines. Examples: processor arrays, thinking machines CM2, MOSPAR MP1 and MP2, Iliac vector pipelines, IBM 9000, Cray XMPY MP and C90, Fujitsu VP-NEC SX2, Hitachi S820, E10. Most modern computers, particularly those with graphics processor units, thus employ SIMD instructions and execution units. Multiple instruction, single data MIST. A type of parallel computer. Multiple instruction, each processing unit operates on the data independently via separate instruction streams. Single data. A single data stream is fed into multiple processing units. Few, if any, actual examples of this class of parallel computer have ever existed. Some conceivable uses might be multiple frequency filters operating on a single signal stream, multiple cryptography algorithms attempting to crack a single coded message. Multiple instruction, multiple data meant a type of parallel computer. Multiple instruction, every processor may be executing a different instruction stream. Multiple data, every processor may be working with a different data stream. Execution can be synchronous or asynchronous, deterministic or non-deterministic. Currently, the most common type of parallel computer, most modern supercomputers fall into this category. Examples: most current supercomputers, networked parallel computer clusters and grids, multiprocessor (SMP) computers, multi-core PCs. Note: many Mint architectures also include SIMD execution subcomponents.